Well, good afternoon, everyone. Thank you for attending today's webinar, Is Your Data Ready for Geo-Enabled Elections? My name is Amy, and I am the Operations Manager here at National States Geographic Information Council. If you are unfamiliar with our organization, NSGIC exists to advance effective national coordination of geospatial information by supporting state-level cooperation. We serve as a national forum for the development of capable and future-oriented geospatial leadership. If you'd like to more information on how to get involved with us, please visit our website, www.nishjig.org. I will pop that into the chat box shortly. Some reminders for today: all attendees have been muted on entrance. There will be time at the end of the presentation for Q&A, so please place your questions into the chat box. They will be answered aloud and at the end of the presentation. Additionally, a recorded version of this webinar will be made available afterwards, so be on the lookout for an email. And with that, I'd like to introduce today's presenters, Sheila Stephenson and Kevin Sigward. I will now turn it over to them. Thank you again for joining us. Kevin and Sheila.
Thanks very much, Amy. Really appreciate it, and we appreciate everybody taking an hour out today to join us for this webinar on Geo-Enabled Elections. I'm Sheila Stephenson, CEO for 1Spatial Inc., and I'm joined today by Kevin Sigwart, who will be what I'd really call the master of ceremonies. He'll do the majority of this. And first off, I'm going to apologize for the really bad light on me. I am not in the most ideal situation. I'm in a hotel business center, but you do what you got to do. All right, Kevin, you want to jump into the next one? So I think, especially after events of late, most people really understand that data quality is key to elections and actually the election data, because what we have all witnessed is a loss of trust in systems by many, questioning the integrity of elections. And, it has caused a lot of uproar in the press. And, the bottom line also, can delay things and really wreak a lot of havoc. And not only that, it is a very costly event. The example given there, I think we've seen a number of them over the years, but in this one particular one with for Washington's 2004 gubernatorial race, costing over, pretty close to $1.2 million because of having to do recounts and those sorts of things. So it is no trivial matter, and the quality of election data is really critical. So you want to go to the next one, Kevin? So 1Spatial focuses on data quality. For those of you who aren't familiar with us, that is all we do. We are a data management solution provider. We started many years ago out of the United Kingdom in Cambridge Labs. And since then we've evolved into a very global company, having started over here about 7 years ago as 1Spatial Inc., which is our organization, which is a US company, but a wholly owned subsidiary of 1Spatial Group, which is the UK parent company. And when we first started 6.5 years ago, we had 1 or 2 clients. And that was US Census and Arizona DOT. But as you can see, we have grown considerably since then. And this is just a small example of the number of different clients in the different areas that we work in. We are very focused in government and doing a lot of efforts within spatial data infrastructures and next generation 911 and just overall data quality and data integration solutions and data supply chain solutions. And we can continue to work with Census as well as other federal entities such as USGS. And then we also are working quite a bit in the transportation space, which is like, as you see here, there's Kansas, there's Massachusetts DOT, there's Alabama DOT, Arizona DOT, Caltrans, and a number of other ones. And then I like to point out the Google work that we're doing within the real estate worldwide services. And that is basically where they do all of their management of their campuses around the world. And I like to point this out because we are data agnostic in our validation and our enhancement of data. And so in the case of Google, there is no spatial or true spatial data there. There's only computer aided drafting data as well as asset management system data. So again, and we're able to do these cross validations of systems that will ensure data integrity. And this is something that's very important when you start thinking about election data and its integrity. So with that, I believe I'm going to pass it over to Kevin. And as I said, he'll take up the lion's share of the presentation.
All right. Thank you, Sheila. And as Sheila mentioned, she brought up a lot of different use cases in a lot of different industries that may or may not be directly related to geo-enabled elections. But a lot of the stuff that we've learned by working with these organizations with their data challenges, a lot of those same issues exist in geo elections. So taking that subject matter expertise in those different areas and applying them to geo-enabled elections. And that's going to be a recurring theme as we go through this presentation is, some of the work that we did for this particular customer on this particular use case really applies to this particular example. So keep that in mind as we're going through the presentation today. Sheila mentioned that, one of the areas of election integrity is making sure that the foundational data is accurate as possible to make sure that you're not going to run into a data issue when some sort of election issue pops up. You want to make sure that's not really data related. So some of the inherent data issues that we see, in geo-enabled elections as we're working through with organizations, is that even still today, not everybody, but even still today, a lot of these election systems are still non-spatial tabular based systems. They are basically, they work with a data set that identifies, okay, if you live on this street within this address range and you're on this side of the street in this municipality, you're voting in this district for this particular election boundary data set, right? And while these systems have been in place a very long time, it's really hard to understand what is going on in these non-spatial systems when you're really trying to solve a spatial problem. If this is really a spatial problem that you're trying to solve, is that if I live at this location, I should be voting on these different initiatives for these different candidates and so forth. It is a spatial problem. So trying to solve spatial problems with non-spatial systems is just asking for trouble. But sometimes you still have to interface with these types of systems, and we see this throughout other industries, and I'll talk about that in a second. But so if you are going to, if you still have these legacy systems, being able to tie those back to a geospatial enterprise can really help you at least identify if there's some sort of irregularities in your particular data sets. So trying to match, these voting tables with, your road centerline data or your addressing data sets. But if you're going to do that, you have to also make sure that your actual framework data sets are good quality. So that's something else that we'll come back to later. But then beyond that is that, say you're working with geospatial data sets for your voting districts, are they actually aligned to your foundational layers? Like your road center lines, when they're supposed to be aligned to the road center lines, or other boundaries, are they aligned to themselves? And in many cases, organizations are collecting some of these voting districts from the local jurisdictions. It's kind of like a roll-up process, like in other data supply chains. So making sure that, as those data sets are coming up, they don't have those types of alignment issues. And then also, making sure that, your address points are in the right district or right location. So these are just some of the inherent data issues that come up as you're working in geo-enabled elections. And this, for people on this call, people that have been members of an district for a while, this should sound really familiar. We've been hearing about these types of problems through next generation 911. We're also starting to hear about it in, with dealing with broadband or assessors offices. They're all very similar issues. And So, organizations can piggyback off of their next generation 911 efforts. We've certainly done a lot of work in next generation 911, working with a number of states. Many of them are members of NSGIC, and working with them to help them with, cleaning up their next generation 911 data through automated validation processes. So we could take those initiatives and expand that into working in the election world. So just a step back, if you're going to, start thinking about, moving to a more automated approach, because when you're dealing with election data, you're dealing with a very convoluted set of boundaries, because, depending on what there's different school boundaries, or, and so forth, there's all sorts of things you have to deal with. So the key is to, first of all, you have to understand, where are these different data systems? Where are these framework data sets? What systems does this need to support? And really get an understanding of the entire layout. And to do that, it's good to just kind of set up a data management plan, understanding all these different systems that you have to interface with. And once you start identifying those systems, you can start to identify, well, what do these systems require in order to work properly? And that's where you can start defining business rules to identify quality issues that could cause issues in any of these different systems. But as you're working with this, you can start to cross-reference, some of the elections data with your other spatial data sets in your geospatial data frameworks, or maybe your spatial data infrastructures. And that kind of brings us back to like having a good foundation set of data sets. If you have a really good set of foundation data sets, this can really help propagate to other challenges that you may run into, like working with geo elections or working with broadband or next generation 911. Having that nice framework data set makes those problems a little bit more manageable, and having a good management infrastructure to support those things. But once you kind of get that down, you could start to build automated workflows, because now, once you understand the inputs and the outputs and the different challenges or quality challenges, you can start to automate the process of doing that. And we're going to talk about that in a lot of detail in a few minutes. And then also, as you're doing some sort of data automation, is having the ability to validate across these different data sets or across the entire enterprise. Because if you just look at one individual system, you may not discover sort of quality issues if you're not like comparing that across the entire enterprise. So looking at not just the voting system or the voting data, but comparing that to your existing boundary data or your road centerline data, or what have you. So this is one example of a workflow for dealing with geo-enabled elections. It's not the end-all be-all for working with geo-enabled elections. That really goes back to every single organization has different inputs and outputs. So identifying what those are and building a workflow to support that. So this is an example, but they all still, generally you want to start with your framework data in general, making sure that those underlying data sources are valid and correct. And we'll talk about that in more detail, but when you're doing those types of validations, you may start to see, well, there's a lot of quality issues in my existing data set, and this would be a lot of effort to maintain manually. I may not have the people power to manually correct all this. So providing some sort of ways to automate the process of doing some of that data correction. When you're doing automated correction, you can't necessarily automate everything. Sometimes it requires some sort of manual review or requires some sort of manual cleansing. So there's typically some sort of manual cleanup effort as part of that. If you're in this case, we're going to be dealing with these non-spatial voting district tables. So validating those to make sure that is there issues when you compare that to a road centerline data set. Once we do that, we can then identify relationships between the spatial data and a non-spatial data set to automating the building of election boundaries. We can even flip it. So say, for example, if your existing system is expecting a non-spatial table, you can maintain all the data in a GIS and then automate the process of generating that non-spatial table that would feed that voting system. And then also is that if you have a a nice, cleaned, aligned data set between all of those foundational layers and the voting data. When you update a boundary for redistricting, that can propagate through. So you can leverage topological tools to just auto update or update all the boundaries when you move a boundary. So having that particular workflow in place. So let's start with step one is how can we look at our foundational data sets? What are some business rules that we may associate with that we can run against those to identify if there's if we're going to run into some downstream issues with this particular workflow. So what we're going to do is we're going to validate some boundary data and some road centerline data. We're going to do some typical addressing checks because you're going to see why in a few minutes because of the downstream effect that this will have if there's some quality issues. So we're going to run some of the similar next generation 911 type of validation checks that we already run. And we're going to do some additional validation checks looking at like boundaries and how they associate to road centerlines and also boundary to boundary alignment. So doing all those different types of validation checks. So with that, let's take a look at some data and actually dive in a little bit deeper to the data itself, because that's what I like to do. I like to look at data. So what we have here is we have some road center lines, and inside and I also have some boundary data, and then I also have this table here. The road center line is your typical road center line. I'll just go ahead. Let me just select a record here just so that we could see what we're dealing with. For a given road center line, we have information about what the road name is, the address range, the municipality. We even have some alias names too in here. So this is other information we can use later on for doing some linkage. And then I also have, I have a boundary data set. So in here we have, which municipality it is and so forth. So we can use this to cross-reference our road center line data. And we have this voting table. So I'm going to open up this voting table. Oops, let me turn that off. Okay. In my voting table here, I have the information like the street name, the address range, which side of the street it is on, the municipality, and what voting district that particular, if you live in this particular range where you're voting for. So these are some of the data sets that we're going to validate, and I'm going to go ahead and actually run some validation checks against that. So let's go ahead and flip over. So here we have some workflows that we pre-configured inside of some of the 1Spatial technology. And there's 4 different workflows that we're going to be going through today. And the first one is we're going to do some validation of some of those framework data sets. So I'm going to go ahead and submit some data for validation. Let me see if I was having issues with this before okay, here we go. Sorry. It's hard to find the data. It's hiding behind all these Zoom windows. All right, so I'm going to go ahead and upload 2 data sets if I actually do it right. There we go. And my road centerline data. And we're going to hit continue. Okay, so I'm going to upload some data for validation. Now, in this case, we're going to be validating those framework data sets. I'm uploading those to be validated. In some cases, your workflow may be, I'm going to be collecting election boundary data from different localities because they may be managing those particular boundaries. So this could also be a workflow where you can have set this up so that a way for organizations to submit you that election data, you can pre-validate that data before integrating it into your statewide data set. Is it aligning to your framework data? If it is aligning to your framework data, if it's not, identifying those issues, is it aligning to itself? Is it overlapping other other jurisdictions that are around that? Things like that. Now, as part of this process, you may have your business rules all running against a specific schema. And we know that when we're working with organizations that are outside of your organization, they're managing their data in likely different schemas because they have their own business processes. So this provides a way for them to do that schema mapping step. So they can map their schemas to your schema. One-time deal, they can save that schema out, and then next time they upload that data, it will use that schema. So we're going to hit continue. But back to this particular use case that we're talking about here, we're going to validate that boundary data and that road centerline data. So we're going to look at those 2 different data sets, and we're going to compare them to see if there's issues. What we typically find is that when you're collecting or you're bringing in data sources from organizations that aren't necessarily working together, they may be working in some sort of silo, is that you're going to find issues where things aren't necessarily aligned perfectly correctly. we can work on that. You can work on that with building data governance structures, identifying what the authoritative source is, where that authoritative source is, and then encouraging your different organizations to use those authoritative sources, because you can have an open a data portal with your authoritative municipality or county boundary data set. But if organizations that are editing their data that are responsible for those particular data sets aren't using those boundaries, you're going to run into issues when you're trying to integrate those. One of the ways you can do is you can validate those types of issues beforehand as they're coming into to ensure that everybody's using those base framework data sets. So in this case, we're running those validation checks. We're running some essential geometry checks, identifying different geometric issues inside of the data set, some connectivity checks, addressing checks, like I mentioned before, address overlaps and gaps. This is going to be important when we're trying to match that road center line, that voting MSAG table to the road center line. If there's overlaps and gaps, that could cause issues for that mapping. And then also when you're looking at the road data, is it actually saying it's in the right boundary? And these, if these are off, this will have downstream effects, can cause downstream effects. So we're going to go ahead and continue, and we see that there's some quality issues. That's good to know that there's quality issues, but we need to also be able to know how to correct those issues or what to correct, so we can download those results, bring those back into the mapping application, and see where those issues are at. So if we come back over here, I'm going to zoom out. I can see where my validations, quality issues are in the map. We can see where we have some issues, and even though it looked like we had pretty good conformance, we still have quite a bit of cleanup work to do. And just to see what some of these issues are, here's an example of where the road center line isn't aligned to the boundary. If I select both these data sets here, look at the attribution for this particular road center line, it's saying that it is supposed to be on the boundary of this municipality, but we can see that it is actually not aligned to that municipality. So this could have topological effects later, and I'll show you how that works later, but we'll get there. Here's an example of where we have a kink in the network. Same thing. This can cause downstream issues. Being able to identify exactly where the issue is at can help organizations correct this in a more efficient, quick way. And then, addressing issues. So here's an example where we have an addressing issue. So here for this particular road, if I look at this road and it's connected to this road, the address ranges shouldn't overlap. And in this case, it goes 321 to 441. If I look over here, this one goes 443 to 451. So there's a little bit of an overlap. And then this one here also overlaps too, overlaps with all these. So there was, when the organization with whoever was managing this road center line was creating these splits, they didn't update the address information correctly. This will all make sense on how this ties back in a few minutes. But the point here is that we're validating the data, identifying quality issues that could cause downstream issues that were identified, when we were building that data management plan. This can be, as I mentioned before, like seeing all these quality issues may, give some people a little bit of heartache. This is a lot of work to clean up. So this is where we get into the automation piece. So I'm going to flip back over to my slide deck real quick, and we'll talk about the automation piece. So what we can do is we can automate some of that cleansing. We can snap features together. We can build, we have technology, 1Spatial has technology and business, and have built workflows for doing some of this auto correction. One of the examples that I like to highlight is, some of the data alignment workflows that we've been working with most recently. We actually started doing some work for LA County Public Works. We have wrapped up that project, but their particular issue was they got a set of census block data that no longer aligned to all of their jurisdictions. So the maps weren't aligned. It was causing issues when they were trying to do some sort of analytics. So they asked us to help automate the process of realigning their boundary data to that new census block group. And that's also led to some work we've done for Michigan, also doing nearly almost the identical workflow. But what we've built is through this workflow is the ability to take up to 10 layers and auto align those 10 layers based off of a base layer data set. So you could throw in things like road center lines, hydro data, the county, census blocks, and so forth, and get those all auto aligned. And to do that, we try to shoot for 90 to 95% automation. And in LA, I think we were around 95%, and then in the Michigan project, we were right around 97% automation. So being able to alleviate some of this pain of trying to actually correct that data in an automated fashion. So let's take a look at that real quick. So we're going to go back in and run another workflow that we have here. And this particular workflow, we're going to do the auto cleansing. So I'm going to submit those same two data sets. Of course, it's going to hide under my Zoom stuff again, but okay. I should just minimize it. All right. Okay. We can grab the road center line and we can grab the boundary data. This time I'm going to run this to completion. So we're going to go ahead and just go into completion. I could set this up. They send me an email, but we're all going to be watching it run live, so we don't have to worry about it emailing me. So basically, now in this case, we're going to take that road center line data set, that boundary data set. We're going to auto align them. Not only are we going to auto align them, we're going to also look at the attribution. Is there things that we can infer looking at both those data sets to do some additional auto correction? We're also going to remove some of those like kinks in the network and things like that. So basically a very similar process. We're bringing in that road data, bringing in that boundary data, running some cleansing workflows or cleansing processes. And then we're going to rerun the validation checks to see, well, are we improving the quality of the data after we do this cleansing? What is still left in there to clean? Because as I said before, we might not necessarily be able to clean everything. If we can get 90, 95%, that could significantly help, some of the with some of the cleanup effort, but there may still be some sort of manual intervention that you need to address. So that's what we're seeing now is we ran the cleansing. Now we're seeing what the remaining validation results are. We're improving, but we do see that there's still some issues left to address, and we'll see that in the map in a few minutes. Not in a few minutes, maybe about a minute and a half. One thing to note is while this is running is that I'm loading a pretty significant amount of data. We're doing this all live, so we're bringing in some 12,000 features of road centerline features, 37 boundary features. We're running it through auto cleansing, we're validating it, and we're writing out those results. And we're doing that. It takes about a minute and a half to run all of that processing. So just the technology that we're using at 1Spatial or 1Spatial technology can really handle extremely large, complicated data sets in a very performant manner. To do these complex analysis and complex validation checks, especially when you're going to see what we're going to get to next after we get through this the initial validation and cleansing. So we finished running those validation checks, cleansing, validation. Now we're writing those results out. We can then go ahead and download those results and take a look at that. In this case, I'm going to write out the results into a separate data set. But if this was in your enterprise system, you can actually automate the process to just automate the process of running it right back to your central database repository. Or it could even, if you're using, Esri versioning, you could write it to a version and then review that and then reconcile and post that back to your enterprise database, your, I guess the master version of that data set is. So we did that. We can download those results. We could bring those back into my application, my mapping application, and see what those look like. So if we come in over here and look at one of the examples of where we didn't have the alignment. So this is before the alignment. We can then do after the alignment. Now, if I turn this up, this was the road center line. So now you can see the road center line is actually aligned to the boundary itself. If we went to where that spike was, before we had that spike, when I turn this back on, we can see that that's been corrected. And then we can identify what existing issues need to be addressed. A lot of these existing issues, like zoom out a little bit, is mostly around some of those addressing issues with the overlaps and gaps in the address ranges. A lot of that would be cleansed typically at the local level as you're supporting something like a next generation 911 that can really, by the time you get through next generation 911, you should have a nice, a pretty good clean road center line data set without overlapping address ranges and so forth. I completely skipped over also doing a fishbone analysis, but you can also, associate road center address points to road center lines. And the reason why, let me just show that real quick. I know I kind of went out of order, but I'm sure you guys can forgive me. In some cases, you want to associate the address point to the road center line. This is done a lot of times in next generation I1 to make sure that your road center line address ranges are all attributed correctly, making sure that there's not a missing address point and not associated to the road center line. But in this case, we're doing it because we know that we're going to be associating an election table to that road center line. So we want to know, are we missing information? Is there some sort of matching issue between the address point and the road center line that could propagate into the voting table? So for example, if we come over here, we have a bunch of address points here that aren't matching. What is the markup? So we have a bunch of address points here that aren't matching to the road center line. And if we look at these here, what's happening is the road center line is, state highway HWY, and the actual address point is spelled out state highway. So there's that mismatch in the way that the street name is represented. So if it's happening between the address point and the road center line, what is the likelihood that it's also going to happen inside of that voting table that we looked at before? So just being aware that these issues could propagate through is something that could be important. Also, another example of something that may cause some downstream effects is that when you're doing that fishbone analysis, you can see that if in a given address point, is it associated to multiple road center lines? And if it's associated to multiple road center lines, that means you have some sort of addressing overlapping going over across all these different road center lines. So the same issue is that if you're trying to match that voting table to that road center line, if it's going to get matched to multiple ones, you may end up having an issue where the voting district associated to this particular road center line may be wrong because it's getting matched to the actual wrong center line. We'll get into that in a second. It might make more sense in a few minutes. All right, so let's come back to the slides real quick.
Hey, Kevin, can I ask you real quick, do you want questions as they come up, or do you want me to wait till the end?
Oh, that's a good question. I guess it depends on what the question is.
It's around topology and that show topological errors that are actually just sort of anomalies, because they're legitimate, but they're problematic.
Okay, can you ask the question in full? I'm sorry.
Okay, no.
Yeah.
Have you had to account in your automated workflows for topology errors that are actually just problematic, but legitimate features of a boundary file? On my team, we often work with, for example, city council districts, which often have sliver polygons, gaps, and holes that are legitimate geographic areas that are separate from council districts, meaning unincorporated areas, state park land, certain bodies of water, et cetera. Do we have a unique way of dealing with issues like that?
Yeah, that's yeah. The devil's always in the details, right? When you're doing some of this automation processes, and yes, we inherently have to deal with those issues. And we have time. I'll spend a few minutes on this. So typically, when we run into these, we'll set a really small initial tolerance for doing the auto snapping, like significantly small. And then what we do is we try to identify where these types of issues are occurring that are legitimate based off of the relationship. Like, is this in a specific, is it for a specific data type? Does this particular class have a different relationship? And using that information to identify how it should snap to those particular boundaries. And then typically what we'll also do is that in the engine, we'll identify when we're doing the snapping, confidence scores on those snappings, and certain objects and certain layers may get a higher confidence or a lower confidence score that requires it would require some sort of review. And then in that case, you'll have a process for looking at those anomalies that want to be reviewed based off of a low score, and a user could go in and accept and reject those as they're going through. And some of that's where we kind of get into that, where we can automate, 90, 95%, and you still have that last 5%. That's where we're starting to talk about that last 5%. And the key is not just to blindly do it, but to have a process where you can identify those types of anomalies in the data to actually either ignore or reject based off of that, based off of a set of business rules. And that was kind of a word salad in a way, now that I'm thinking back, but I guess in short, go ahead.
Yeah, and if they have further, I'd say if they have further question on that, we could, when we get to the end, go deeper into it. But one of the things I would say, and you can correct me if I'm wrong, Kevin, that's where the exceptions tables come in, because you can have things in there that mark those things that, so they leave them alone.
Yeah, yes, sort of, yes. Like basically kind of like an exceptions table, except this is more like a proposal table where you're proposing the changes as opposed to marking up those issues. But yes, good. Yeah. So actually, anything else you want me to continue on?
Move forward, and then and then I'll ask the person who asked that question if they want to dive deeper afterwards. Just let us know.
Perfect.
And she did make a comment though that's really interesting and affirming for someone who has tried to automate dealing with these issues. It's hard to account for those little nuances. Thanks for your thoughtful answer.
Yeah, no problem. Thank you. Okay, so which brings us to a good point, right? What do you do with that remaining 5%, right? This is where, and this kind of comes back to that like the level of what the governance is and what the data set is. Who's responsible for actually editing that data? You don't necessarily want to automate the process of, you don't want to automate necessarily the process of cleaning your addressing data, because the locals are really responsible for that addressing data. So in those cases, you want to identify the issues and push that back to whoever the authoritative source is to do some of that data cleansing efforts. On the alignment side, in many cases, especially when you're dealing with boundary data, this can be really controversial. So bear with me, right? Is that typically GIS is really, you're not building survey grade boundary data sets. It is a representation of what the real world is. It is not saying what the real world actually is. It's not. There's no way you're going to have a survey grade boundary data set that is that doesn't have so many vertices in it that it would be impossible to do any sort of analytics against it. So the goal is to generate a data set that is aligned so that you can do these analysis and you can do these analytics against, get agreement on the different jurisdictions that surround that boundary on, yeah, this representation is close enough for us to do our analytical work against. This is all related around data governance. We could do a whole 2-hour presentation, which we have on data governance. We're not going to do that today, but then when you get to, either way, when you get to the automation piece, you still may need to address, because there are those corner cases where things shouldn't be snapped that snap, or things that you don't want to, or things that didn't snap that you want to snap together. So that's that last 5%. The key is being able to identify where those issues are, and then driving a user to manually correct those issues. So say now we talked a lot about those framework data sets and getting my framework data in place. That no matter what your election system is like, that is it's going to be it should be a requirement for all organizations. We all want to have a nice, clean spatial data infrastructure. But now we can talk about a more specific use case, and this is a use case where we're dealing with that election table. So in this case, we have that election table. I showed it before, and what we want to be able to do is we want to match it to the road center line, mostly to help us generate a boundary, but we're also doing it for just validation. Are we missing something? Are we missing any sort of data inside the election table? Are we missing data in the road center line? And the best way to identify if we're missing that information is to compare the two and see where there's gaps. Now, there may be gaps between those two that are legitimate gaps, but there may be gaps that are just missing, you're missing data. So doing that analysis, you can identify those anomalies, and then you can identify whether or not that is a legitimate anomaly, or if there's some sort of quality or missing data in your data sets. So we have a workflow for dealing with this. I'll kind of walk through this in some slides, to help illustrate that, and then we'll go and actually dive into the demonstration piece of it too. So here's an example where we're trying to match that voting table to a road center line table. So we look at the street name. In this case, there's an exact match. That's helpful and useful. And we look at the address low and the address high, and look at the address ranges. And also, what's not shown in this table here is also the odd or even. So you can also look at whether or not this is odd or even, identifying that match to those particular records. So identifying where those particular, what these records should match to this record, and identifying those. Now, there are cases where it would be nice that everything is using the same naming convention, but we know from working even within an organization, the same organization that is working with the two different data sets, that sometimes those don't align up, like that example I showed you with the address point and the road center line. So when you're bringing in a data set from another agency that's working completely likely in some sort of silo, it propagates even more. So being able to use fuzzy matching is something that is a useful tool. In this case, we're matching these records together, but we're not just using we're not just using a direct match, we're using different algorithms. So we have a couple different algorithms that we typically use. We use one called a Geo-Enabled similarity model, another one, a Levenshtein distance model. They have different ways of looking at strings. We also have a SoundX model, and typically we can use that and then take those confidences and generate a total confidence based off of those different algorithms. So you can match something like a turntable junction with turntable JCT, or Prospect Hill Road with Prospect Hill, or things that are just this is a funny one, super fine road, or super space fine. So identifying these matches, then you can have that association. So that's just a useful tool for doing this type of matching. Once you do that, you then can in effect overlay the election table, georeference it onto the network, and visualize where those election records actually sit geospatially. So now we're taking that non-spatial data set and visualizing it spatially, which will help us potentially identify any sort of anomalies in the data set. This is very similar to a lot of the work. Come full circle back to what we were talking about before. You're probably like wondering, why is Sheila talking about DOTs when we're talking about geo elections? Well, this comes full circle back to why she was referring to that, is that we do a lot of similar work all the time, working with like federal highways, state DOTs, trying to generate event data on top of a linear reference system. And doing that with like traffic data, but for Massachusetts DOT, where we generated an event data set on their linear reference system based off of a separate traffic data. So conflating that information over and building an event. So in effect, that's kind of what we're doing. We're basically doing that here, but instead of using like measure values and an LRS, we're using road center lines and an address range, and we're matching those and mapping those onto the network. When we do that, we can see, well, do we have any sort of gaps where we're not matching that voting record onto the road center line? And then on the flip side is that we can identify, well, where do we have road center lines where we didn't have a match? Well, where do we have records that were in that voting table that we don't have a match on the other side? So the reverse side. And then, okay, well, here's this shows you an example of where we have, Amelia Way. It has an address range of between 2 and 10. But if we look at the road center line, there is no to and from associated to that particular network. So it wasn't able to match because there was no addressing information in that road center line. We would likely have, this is one of those things where that would have been identified earlier on in the workflow when we were doing the validations on the addressing validations. Are they populating those? There's likely some address points along here. They probably wouldn't be able to match, those address points wouldn't be able to match the road center line. But that's why it's important to go back and validate first those framework data sets, getting those cleaned up as best you can before doing these cross enterprise system validation checks, because you don't want an issue to propagate through the entire system. Okay, so let's go ahead and actually show you this instead of just slides, because I like to do things live. So let's go here and go back. So here's an example. Here's another workflow we have. Let me find the right one. And this time, what we're going to do is we're going to submit my road centerline data. And I'm going to have that same issue that I always have where I can't find it because it's hiding behind Zoom. And this time we're going to upload that voting table. Here we go. And we're going to upload a road centerline table or data set. I'm going to go ahead and run this to completion. I think I said this before, but I can flag this to notify me when it completes via email, but we're not going to do that today. Okay, so now what we're doing is we're bringing in that road centerline data. We're bringing in that election table. We're then going to do some standardization because, when I originally ran this the first time, I saw that, well, I have a first street that's written as FIRST street. And then in the other data set, it's with a 1 and F or 1 and then ST street. So can I do some pre-processing? So we actually took some rule logic that we actually implemented for the US Census in our Tiger Centerline program, where we standardize the street when there's a number for the street into either moving into a number or moving into text. I can't remember which way we did it. So doing some of that standardization, leveraging existing rules from previous projects to do some of that standardization. And then we can start to match now the street names and from the road centerline data set and the voting table. And from there, we can determine how well do we match. So in one direction, we're around 87%. In the other direction, we're around 94%. So voting to road centerline and road centerline to voting. Same idea, I could take those and I could download those results and then visualize them because it's a lot easier to visualize these than just talk about it. So let's take a look at what it looks like visually. So if we come back over, let's switch over here. So we talked about this before. We have this voting table that we mentioned before with the street name, address range, the side of the street, municipality, and the district. And then we can take that and associate it to the road centerline and basically overlay it on top of the road centerline. So basically everywhere you see purple here is where we were able to take a road centerline and match it to the voting table. And then where you see red is where issues where we weren't able to identify, there's a gap in the matching. And basically that means is that the street name was there, but there's a gap in that address range is why it's being flagged. So if we take a look at some of these an example of this matching, if I select this particular record here, you're going to see we have 2 records that are at this location, and it makes sense because we're going to have one that's matching to the opposite to the odd side. So this road here with this this address range is matching to this road centerline here. And then we also have the flip side. So we have the even side also. So the even's also matching at this particular location. And as we walk along this, we're going to have those matches going through as we matching all of those voting tables to that road center line. And then, as I said before, we're identifying where we have issues. So here's an example where we have a missing record. And if I look here, this is Slacktown Road, and this is the address range for this particular road center line. So if we look at the voting table, we can see why this didn't match. Let's pull this up and let's see if we can find, can we find Slacktown Road? So I'm going to go and scroll through here until I get down to Slacktown Road. I'm sure, just bear with me. Oh, here we go. We have Slacktown Road. Okay, and I'm looking at the address ranges. Well, it looks like the address ranges are actually within that address range, or maybe not, but it doesn't matter. That's not the point I was trying to get across. But what we also see here is that all of the records for Slacktown Road are all in the municipality for Kingswood Town, but this particular road center line is actually in the Franklin Township. So it's outside of that township, which is why it didn't match. These records didn't match that. So that's why we're flagging that as a mismatch, because we weren't able to identify that a match because it didn't have the same municipality. All right, so if we come back to so we can at least, so now we've identified the matching. We can see if there's irregularities. I can't say that word, so I apologize. But we can see those issues between those two different data sets. And then what we can do is we can start to identify, well, is the issue related to, something with my addressing data set? Is it an issue with my my voting data set? And we can start to reconcile some of those issues. But that's not where we want to finish. So what we want to do next is, if we can identify those matching records, we can start to automate the process of actually generating these boundary data sets. So for example, is I can take that record and I know what's on the even or the odd side of that road. I can see, for a given set of area based off of the road center line, does it all meet a particular jurisdiction? If so, associate that boundary with that particular jurisdiction. Now, to do this, I'm not going to try to go too deep into the weeds here, but I'll go a little bit deep into the weeds. We are in effect, let me check the time real quick. Let me see. Oh, we are running low on time. Okay, never mind. See, I guess I shouldn't have answered that question before. Point is we can do this. I can talk about this further at a later date, but we can automate the process of identifying what the boundaries are. And I'm not going to run it live because we don't have time for that. I swear I practiced and we were in the time frame, but not today. Okay, so here we have we're taking that data set and we're saying, given the even or the odd side, what is that particular section of road associated to which particular election district? And then from that, we can use that information to infer what the boundary would be. Now, there are some quality issues in here. And what, in effect, basically what's happening is at this location, the address ranges it was mapping the wrong, because of address range overlaps, it was mapping the wrong jurisdiction at this location. So it wasn't able to identify what the boundary would be because of that mismatch. If we cleaned that up, we would end up with something like this, where we have we can generate the actual boundary data set from that road center line and that voting table. We can also, as I mentioned before, we can flip the logic and we could take the road center line data, determining where it's split at every single boundary, look at the address ranges, and generate that voting table if it needs to feed a non-spatial system, if you're still using a non-spatial system. And with that, I'm going to come back to my slides just to wrap up. If you are keeping your boundary data all aligned, I mentioned before, you can use your typical topology tools when you're doing your data editing to maintain topology. We do find typically that you have organizations that are working outside your enterprise. So what you want to be able to do is everything that we did before is automated. So you can continue to run these processes of validating data as data is being changed and updated, as you're collecting data from locals, to ensure that you maintain these relationships between these data sets throughout time. So scheduling these validations to run nightly, weekly, or monthly is something that you want to maintain your data integrity. And for a wrap up, I'm not going to walk through this just to save time for questions. And I see that there's 10 questions in that box. I don't know how many of those are questions or comments, but with that, I will pass it back to Sheila to pass it back to me with
Kevin,
questions.
actually, I would say I think these are mostly comments.
Okay.
And I'd also said what I wanted to ask, one, is anybody currently working on these things and having any challenges? And the other thing is that I've offered to a few of the attendees who've asked some questions that if they can provide their email, we'd be happy to reach back to them and discuss further, so we can get into since we are short on time, we could get into some more specifics. So I think, Eugene, you had a question, and there's a few different things that I would say we're considering to your question. And so it would be a little bit longer discussion than just in 3 minutes, even as fast as Kevin talks.
It definitely sped up after I saw that it was 5 minutes until the end of the hour.
Yes. So anybody else have any burning questions or anything else that we can dive into for you? I like it. Jamie says time flies when you're having fun. It always does, because we're always having fun. All righty. Well, I think we can go ahead and wrap up. Again, feel free to reach back out to myself or Kevin or any of our other individuals at 1Spatial, if you know them. And we would be happy to, like I said, do any deeper dives or discuss further. Thank you.
Thank you, Sheila and Kevin, for that wonderful presentation. And thank you to all who attended today. I just also want to give an alternative. If anyone has any specific questions, I popped in info@nishik.org. You can send that to me and I'd be happy to connect you with Sheila and Kevin. Any last words, Sheila and Kevin?
I have one last word. There is also the NISJIC forum too. So you can always post questions to that so that everybody can see them. I'm sure Jamie would appreciate that also.
Good idea. Thank you, Kevin. Once again, thank you, Sheila and Kevin, for today. And thank you to all for attending today's webinar. We truly appreciate your support.
Yeah.
And with that,